Welcome to the AI Ireland podcast, your window into the world of AI innovation on the island of Ireland. Join us as we explore how AI is harnessed to tackle both business and societal challenges, revealing the cutting-edge solutions emerging from this vibrant AI community. Don't forget to subscribe for the latest updates and insights in the world of AI. Hello everyone, it's Mark Kelly here. I hope you're doing really well wherever you are in the world today. We are absolutely delighted to be speaking to the team from IBM, who are finalists for this year's Best Application of AI in Large Enterprise. I'm speaking with Elizabeth Daly and Seshu Tirupathi. Elizabeth is a senior technical staff member at IBM, and Seshu is a research scientist at IBM. Elizabeth and Seshu, thank you very much for joining us on the podcast today.
Thanks for the invite.
Elizabeth, can you tell us a little bit about your project that you submitted for this year's AI Awards, which you've become finalists for?
Sure. So the project that we put in the application for is an interactive incremental machine learning model to provide risk classification for our security product called IBM Security Guardian. The reason we ended up tackling this particular project is that we'd been working, myself and some of my collaborators on my team have been working in the area of interactive AI for a number of years. And in parallel, Seshu had been working on incremental machine learning algorithms. And when the product team came to us with their problem, we realized that it was a really fantastic synergy of these two different disciplines. And we already had quite a bit of thought and algorithms in this space, but we had not brought them together. And the reality is bringing these two things together is what made it something actually feasible for the product.
Fantastic. And Seshu, from a technical level, how challenging was that actually to do, to bring those both together?
It was very challenging. So one of the things that we had to consider was first thing, moving from heuristic models to incremental learning models implies that you want to make sure the scope of the models is much more than before. And what that means is if there is a new risk class, you have to seamlessly integrate it into the existing model without having to start from scratch. If there is a new feature that is contributing to a class, you again want to make sure that it continues from the same space rather than starting from scratch. So this continuous learning with dynamic changes in the features or the target variables is the most important challenge there. And all this coupled with the explainability components that Elizabeth was mentioning, I think all this together as a package is a really challenging task.
Talk us through your solution. And I'm particularly really interested in how it's combining interactive AI with incremental machine learning. And could you explain in simple terms, how does this dual approach help organizations better protect their sensitive data compared to traditional security methods?
So we brought together two strands of research that we've both been in parallel involved in, and it really helps solve the problem of where you train a machine learning model based on your data, and that data, something has changed maybe in the environment, or something has changed in your system, and it no longer reflects the needs of that environment. So let's say you're in a security environment, and it used to be that certain features are the significant predictor for risk classification. And now we have experts who know that this is no longer the case, or there's a new risk that's been introduced. Our solution allows users to correct the logic of the model and infuse that information inside the underlying machine learning model. So we have this combination of interpretable logical rules that act in parallel to a machine learning model. And then really importantly, if you're going to retrain a machine learning model, this is something that's quite expensive. And that's where Seshu's work on incremental machine learning made this solution really possible.
So in a sense, what we are trying to do is if there is an existing machine learning algorithm that has learned quite a bit over the past data, when there is new incoming data, you don't want to again learn from scratch, especially because there are only small changes that are probably required in the machine learning algorithm. So what we've proposed for is basically using incremental machine learning algorithms so that you can tweak the solution to ensure that it matches to the requirements or the current state of the system. And some, like a simple example would be like if there is a brute force attack, probably the number of login attempts would be a good feature to detect brute force attack. But let's say you want to add one more feature to it. What you don't want is to again start from scratch by taking both the features combined and then learn what results in a brute force attack. You want to add that feature and then incrementally learn by learning it from this state of the model rather than from scratch.
What I also found quite interesting was when you look at existing security solutions, they sometimes struggle with static rules and delayed user feedback. And how does interactive AI systems overcome these limitations, particularly in terms of kind of real-time threat detections?
Yeah, so that's where I think the work is really trying to push the boundaries there. We want to take advantage of the benefits of interpretable heuristic rules, which is, as you say, how most security solutions work. But then we infuse that information through synthetic data generation into a machine learning model. And then we can also take advantage of allowing user feedback through individual data points, where we then retrain the surrogate model, which is interpretable, and we keep those two to work in check with each other so that you can understand what logic is infused in your machine learning algorithm, but you also have that logic up to date and taking advantage of all the benefits of machine learning where it's going to learn from data also.
And when you look at some of the tech that's able to distill complex machine learning models into more interpretable rule-based surrogates, could you just walk us through how this works and why it's important for security teams and, as basic as you can make that?
So the main point here is while incremental machine learning models or any machine learning model can work as advertised, it's most important that the user is able to understand what the output is and how that came about. So understanding what features resulted in this detection or in this classification is very important. And so while we've developed the models, we've also ensured that there is an explainability component to it to help the user. And that explainability component is also used in the user feedback as well, because they know exactly why a given class was identified, whether it was brute force attack or an account takeover. So that's taken as with the explanations. The feedback is then easier for the end user to provide. So we basically use that as the basis for improving our models here.
And the underlying algorithm that we used was BRCG, which is an algorithm that's part of one of the Explainability 360 toolkits that IBM has open sourced. And it actually won the FICO Explainability Challenge a number of years ago. And in that case, they were looking to completely replace the machine learning model with this set of interpretable logical rules. However, what we started doing was using it to generate a surrogate to reflect the underlying decision making that an ML algorithm has learned. So instead of training on the raw labels, we're training on the predicted labels from the machine learning algorithm.
And what inspired this approach, and what advantages does it have over traditional black box AI systems? And for a lot of people, they may not understand the different kind of packages that IBM offer in this approach.
One of the things I really like about this work in this project is that it was inspired from working with our internal divisions in IBM to bring AI solutions into production. So we started working with the Chief Analytics Office, and we were working in the context of trying to make decisions for sellers on routing sales opportunities. And we had this data, and we were able to train machine learning algorithms, but then we would present it to our stakeholders, and they would, and not only does it take a lot of time to be able to explain to them the logic that's being learned by these algorithms, they also then, when they would see individual examples, they would say, but the problem is the rules have changed. We have external policies that have now come into place that say that, okay, we used to treat opportunities that are, let's say, in the region of 5K in this manner, but now we treat them differently, and that threshold has been changed to 10K. And so we realized that there was this massive gap in how do you let non-data scientists give feedback into these machine learning algorithms so that they really are in line with, let's say, external policies and so on.
So Elizabeth and Seshu, maybe you could answer it just from a kind of a practical perspective of how customers might use this for anyone maybe who's not too kind of overly technical. What would that look like?
One of the things that brought about this solution is that heuristic rules were not working for most of our clients, and the static-based machine learning models were also not working because there were a number of false positives. So they wanted to minimize that, and so this concept of making sure that the user feedback is integrated into the machine learning solution came about and provided a suitable alternative for the clients to take up. So this coupled with the fact that it was explainable made the user feedback more easier, and so it kind of made sure that there was constant or continuous improvement in the machine learning model, at the same time making sure that it satisfies the client's needs. Yeah.
And one thing is really, really clear from the work that you do is the focus on having human-centered AI and trust. Is there a balance for sophisticated, is there a balance for the need for sophisticated security algorithms while also keeping the system understandable and controllable for users? Is there like a trade-off there, conscious, or how do you kind of come to the table when you're thinking about these different decisions?
Yes. So, I mean, there's definitely concerns in when you're making fully transparent, let's say, a detection mechanism, because it does open up your system to potentially people looking for vulnerabilities. And so that is something that we have thought about. And the reality is that the logic there is in the hands of the administrators. And it's important that they do understand what logic is there, because it could be that there might be a backdoor that's been introduced that could be surfaced through some of these logical rules. There's a great talk by a person called Brian Christian, talks about a study where in a hospital they were doing a bake-off with AI systems and different methods and algorithms, and one of the algorithms they used was a completely transparent, logical, heuristic-based system learned from the data. And what they learned from the data was that patients with, I think it was asthma, had a higher probability of successful outcomes when brought to the ER. But in that particular hospital, the reality is that it's because there was a special intervention for people who were deemed high risk. And so that's an example where the data does not reflect the full logic of the environment in which it's deployed. And because they saw that this logic was learned by the algorithm and by the data, they had to make the decision that they needed to go with a purely transparent, rule-based heuristic system, because they realized their data was flawed. And the way they were able to learn about this inaccurate feature importance from the data that was being infused into the machine learning or AI systems was through this act of distilling the AI system into some logical clauses. So yes, it could be that it's open to attack, but also because it makes it transparent, it maybe means you have a better opportunity to block against those attacks.
Yeah, I kind of like, it's kind of like a double-edged sword. It's kind of an interesting one when you look at it like that. And Seshu, how do you see this evolving then, coming down the track? Obviously, things are moving so fast. I won't even ask you for years at this moment in time.
Yes.
But just even if you kind of think about interactive machine learning evolving in the security space, there's certain challenges, opportunities. How do you see those threats becoming maybe more sophisticated?
I think the data is high volume, the data is high velocity, and it'll only get worse over time, I guess. So the models need to adapt to the changing behaviors of the users, as well as the complexities of the IT systems, the cloud networks, and also the models themselves need to adapt to all these things. And so important that the models are dynamic and can ensure that the user feedback is taken into account. If I can't foresee a situation where static models can work, especially going forward. Yeah.
Brilliant. Well, Elizabeth and Seshu, thank you very much for your time.
Thanks, Mark.
Thank you, Mark.
Membership of AI Ireland placed your organisation at the centre of the fastest growing technology sector in the world today. As a member, you'll have access to our diverse and highly engaged professional community, which is committed to driving artificial intelligence forward in Ireland. Membership of AI Ireland is for any organisation employing data and analytics. We offer memberships to corporate, government and SME organisations. Interested to find out more? Contact Mark at aiawards.ie.